Hi everyone, how you guys doing? Okay, so first of all, let me welcome you guys to the Unacademy JEE English. And let's give it some time for the stream to become smooth. In the starting, it usually lags a bit. It becomes smooth in a minute or so. All right. First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And on this channel, every concept of physics, chemistry, and maths are being taught to you completely in English. Now, this is a series that I host for class 12 students that are preparing for their JEE, which is coming up now in February. So this is the topic that we are discussing today is fluid mechanics, and this is part 3 of the quick review of the fluid mechanics. And today we'll be covering the rest of the topics, and we'll be finishing our discussion and wrapping up this topic. Now, before I get started with this today's discussion, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit, and okay, just a sec. Here it should be. Hmm. Just let me get this thing right. Okay, so how are you guys doing? First of all, how's everyone? Come on, say some hi, hellos in the chat. Okay, now it seems fine. All right, so before we get started with today's discussion, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit, and I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I've been teaching physics for the IIT JEE exams on both mains and advanced. Now, as a student, I myself was All India Rank 447 and All India Rank 192. Now, in the two stages of the IIT exams that I took, I also qualified the NTSC Stage 2 examination, and I was also in top 1% in the NSCP. I've already coached many students to top ranks in the JEE examinations, and let's hope I can continue to. Okay, so yeah, there was some glitch in the software, but it seems fine now. All right, so as I was saying, one great way of doing that is that you get yourselves the Unacademy subscription. The subscription will help you benefit with benefits like live classes where you get to interact with your educators on a regular basis. You also have live polls and leaderboards in these classrooms. You also are a part of test series and analysis sessions, and of course, live doubt clearing sessions. So for those of you who don't know this, every fourth session in your Unacademy Plus courses is supposed to be a live doubt clearing session. So after every three teaching sessions, whatever doubts you have, be it related to the theory, be it related to problem solving, you can get those cleared with the live doubt clearing sessions. Now, these sessions make sure that your doubts do not pile up and you do not feel the pressure of the studies. All right, so hi Motilal, hello S Pandey, hi Amod Kumar, how are you guys doing? Moving forward, along with these benefits, Unacademy also provides you a chance to study from the top educators from all across the country from the comfort and safety of your home. Now, sitting at your home, you can study from all the top educators of Kota, Delhi, and anywhere else that you will get the chance to. Okay, so the first step towards getting this subscription and unlocking the wonderful features is to install the Unacademy app. Now, the moment you install the Unacademy app, you have unlocked yourself a lot of free features, which include free courses. Then there are free special classes, which you can attend just after installing the Unacademy app without even getting the subscription. Okay, so special classes are there which are running absolutely free of cost, which you can join, and of course you have free quizzes. So these features you can unlock just by installing the app, and you can get a flavor of how it's going to be when you get your plus subscriptions. Now, if that is something that you like and you finally decide to get your subscriptions, this is how you do it. You go to the plus section of the app, you select your goal as IIT JEE, and you click on the get subscription button. Now, the moment you are redirected to the payment page, which will look something like this, you will have a box here which will say, do you have a code? That is where you can use this code, RD Live, that is my code. And now you can choose from two subscriptions, which are Plus and Iconic. So, and trust me, the subscription fees have been kept very competitive. So the kind of quality education that you're getting here is completely worth the kind of fees that you pay for these subscriptions. Now, also when you click on proceed to pay, you will realize that you have a lot of no cost EMI options available for you to break that payment into any number of convenient amounts. Okay. So make sure that you are using all of these benefits and getting the best education from the comfort and safety of your home. Now, talking about the iconic subscription, so what is that? That is something which will take your IIT JEE preparation to the next level. So you will be assigned personal coaches. You will be able to attend regular IIT JEE workshops. You will receive expert guidelines from time to time. You will also get a study planner and a regular test analysis sessions. So you get a dedicated team which will guide you, closely mentor you, and will make sure that your JEE journey is a smooth sailing one. Okay. Next, you can also win yourself this subscription, test your knowledge, check your understanding amongst your peers by taking part in the Unacademy Combat. This, if you don't know, is the most competitive gamified IIT JEE battle. And the next competition will be held live on the 20th of December, in which you can now enroll using the code RDLive. Do well there, get not only a good rank, but also win yourself some great rewards and cool prizes, which will include an entire year's subscription. Okay, so for top performers, even entire year subscription are being given away. So make sure you're using that. Now, also you will be getting now a chance to study from the top educators of Bansal classes. All right, so Spark Batch is announced for JEE 2023. So all the top educators of Bansal classes are going to be taking those classes. So make sure you are getting this opportunity to study from the topmost teachers. All right, those of you following us on the JEE English channel can connect with us on the Telegram app using this link. So this will make sure that you are not missing out on anything that is happening on this channel of JEE English. Okay. All right. So why don't we finally get started with today's discussion, which is about fluid mechanics and part 3 of the review. So good evening, Rajesh. How are you? All right. So today we will start our discussion with fluid dynamics. In the last class, I discussed things about fluid statics. We talked about how pressures vary. We talked about Pascal's law, how to apply those. We talked about Archimedes principle and how to solve problems using that. We learned a lot of tricks. Today we will be shifting our focus to the behavior of fluids when they are in motion, and that is called fluid dynamics. So let's get started. So first of all, we will try and classify the flow of fluids. Okay. So when you talk about the flow of fluids, you have certain kinds of characteristics of a particular kind of a flow. So if the velocity of a fluid at any point of the flow does not vary with time, then such a flow is called steady flow. So in our analysis of moving fluids, we will only be studying these fluids which are exhibiting steady flow. So what is steady flow? So something like this. So when it appears to be something like this is called a steady flow. Okay. So the first characteristic of the steady flow is that the velocity of any particle at any position in space does not vary with time. So imagine if you have a pipe of water and you have switched on the tap. Now, after a while, you realize a steady flow is established and a steady flow of water is coming out of the pipe, right? Now, what happens if you keep changing the tap's openings? Okay, so if you keep modifying the tap, if you close it partially, open it more, close it partially, open it more, then the speed of the flow keeps on varying with respect to time. So that is an example of a non-steady flow. Okay, so I hope you realize the difference between steady flow and non-steady flow. So while a liquid is flowing through any pipe, so imagine a fluid is flowing through this pipe. Now, if I focus at any one point in space, okay, so let's imagine I am focusing on this point. So whenever any particle is passing through this, it should have one velocity v, and after every time interval, another particle of fluid that will be passing through this point, if it has the same velocity v, then such a flow is called steady. Now there is another kind of flow which we keep called streamlined or laminar flow. So what is that? In that flow, you will realize that if fluid particles are passing through the same point and follow the same path, then such a flow is called a streamlined or laminar flow. Okay. For example, when you have such a constant flow, so this is both steady and laminar flow or streamlined flow. Okay. So imagine a pipe of water carrying water from it, and the water is flowing at a constant rate. So also the direction of those water particles is not changing. So this is an example here of laminar flow, and this is an example of a turbulent flow. So imagine now if the water pipe is put in a bucket. In bucket, when it is flowing, it starts to swirl around. So that is a turbulent flow. As long as the fluid is moving in the water pipe, it is moving straight, it is moving in straight lines, it is not circulating, then you call that flow laminar flow. Okay. So do I need to do theory of relativity too? It is in HCV. Yes. So ARJ, so the theory of relativity is there in HCV. You are right, but that is not part of your JEE syllabus. So HCV is about fundamentals of physics. So there they have talked about the theory of relativity, but that's not in JEE syllabus. So you do not need to study that. Okay. Hi Tanya, how are you? All right. So I hope it is very important before we study the fluids which are flowing, we need to categorize their flows. So we will only focus on a flow that is both steady and streamlined. Okay. Now consider a flow in which there is water flowing through a pipe. Okay, but I slowly keep on increasing the pressure of water by the tap. So if I open the tap partially initially, and if I keep on increasing the opening of the tap slightly with respect to time, then you realize all the water will be flowing in straight lines. So the flow would be laminar, but it won't be steady. Now, when I stop adjusting the flow of the tap, now once a steady amount of water keeps coming out from the tap, now the flow is both laminar and steady. That is the only kind of flow that we will focus on. Okay. All right. Moving forward. Now we'll talk about something which is called principle of continuity. So what is principle of continuity? So you realize that if there is any section of pipe which is carrying water, then you realize for that section the mass of water that has to enter has to be equal to the mass of water that is leaving the section. Okay, so if m1 mass is entering per unit time, which is represented as m1 dot, and m2 mass is leaving this section per unit time, then we believe that m1 dot would be equal to m2 dot. This is called the principle of continuity because the mass can neither be created nor be destroyed. So if the mass is traveling, then for any section, if m1 mass is entering the section, then m2 mass has to enter the section. That is assuming that your pipes are in unstretchable. Okay, so that is for unstretchable pipes. Okay, so that is where we use this equation. So as it is here mentioned that when an incompressible non-viscous fluid, okay, so that is another thing. We will only be talking about non-viscous fluids. So what is viscosity? I'll introduce that right now quickly. So viscosity is the resistance of the flow of two layers of fluid, which opposes the relative flow of two layers. Okay, so when imagine when you throw water on a surface, wet surface, you realize that the water at the bottom will come to and stop right away. The water above it will flow, slow down, and eventually come to stop. So that is because the upper layer of water will feel a resistance in flow due to the lower layer of water. So that resistance is called viscosity. However, in our study of flowing fluids, we will not consider the force of viscosity. We will treat our liquids as non-viscous. These are ideal fluids. So ideal fluids are incompressible and non-viscous. These are the only fluids that we will focus on. Okay. So as I said, if an incompressible and non-viscous fluid flows in a streamlined motion through a tube of non-uniform cross-section, then the product of the area of cross-section and the velocity of the flow remains constant at every point in the tube. What do I mean by that? As I said, for any section, the amount of mass entering has to be the amount of mass leaving. Okay. Now, if the liquid is incompressible, which is the kind of liquid that we deal with, then you realize this mass can be written as rho A V1. Okay, this is the mass that will enter the fluid from section number 1, where V1 is its speed here and A1 is the area here and rho is the density. And that would be equal to rho A2 V2 for any other cross section. Okay, so the amount of mass entering should be equal to the amount of mass leaving, which will essentially mean that rho will get cancelled out and A1 V1 equals A2 V2. This is called the equation of continuity. Okay. So for every point in the tube, you can take here also the product of the area of cross section and the velocity, which represents the amount of volume flowing through that cross section per unit time, always remains constant. Okay. So as I said, for compressible fluids, the density could have changed and you would have had this equation for continuity. Okay. And this is based on the principle of conservation of mass. Okay. So You are most commonly aware of this equation, A1 V1 equals A2 V2. Again, this is based on principle of conservation of mass, and this equation takes this shape only for an incompressible liquid. So where you assume that the density is not changing. If the densities were changing, then you could have used this form. Again, you don't need to bother about this form until unless you're talking about advanced. I don't think in mains they will ever bother about this. In advanced also they usually don't. Okay. But however, I just wanted to show you in principle, this is the actual equation. Okay. All right. Next, another very, very important tool for our analysis that we will be using is called Bernoulli's theorem. Now, Bernoulli's theorem states that the work done on a unit volume of an ideal flowing liquid in a streamlined flow is always equal to the sum of changes in kinetic and potential energies per unit volume as the flow occurs. So the equation that you get is P1 plus rho GH1 plus half rho V1 square equals P2 plus rho GH2 plus half rho V2 square. So essentially what you're trying to say is you are applying work energy theorem. This is nothing but energy conservation. And it just tells you that the sum of these three quantities, pressure, rho GH and half rho V square at every time is constant. Now, if you realize your rho GH, what is this term? This term is called the potential energy per unit volume. Potential energy per unit volume. Okay, this is the kinetic energy per unit volume. Now this is called pressure energy per unit volume. Okay, it is numerically equal to the pressure. So you realize since all fluids can exert pressures, so that thing gives every liquid an ability to do work. And whenever you have ability to do work, we say that that thing has energy, right? So that is what pressure energy denotes. Pressure energy denotes the ability of the liquid to be able to do work due to its property of pressure, being able to exert pressure. Now, pressure energy per unit volume, if you try to measure, it is numerically equal to the pressure. So essentially what this tells you is that the sum of these three energies is always constant. So this principle is based on the law of conservation of energy. Sometimes this is also denoted like this. Okay. P over rho G plus H plus half square over G is constant. Okay, this again, what you're doing is you're dividing the entire equation with the help of rho and G. Okay, then this equation takes this form. Now this is called the pressure head. Okay, this is another form in which you express Bernoulli's theorem at times. This is called pressure head. This is called gravitational head. And this term is called the kinetic head. It's just another way of representing the same equation using new terms, but you should be aware of those terms because sometimes in the question they can express these values like this. They can tell you that the pressure head is this much, the gravitational head is this much, the kinetic head is this much. So you should know what any head means. Okay, what is the expression that any head is representing? So pressure head is P over rho G, gravitational head is H, the height of the fluid, and we take the height of the center of mass of the fluid, obviously center of the pipe, so to say. And then kinetic energy, kinetic head is V square by 2G. Okay. Next, what are the applications of Bernoulli's theorem? Very, very simple. So one very interesting application is in the airlift of an airplane. So you know this is the shape of the aerofoil. So what happens is that imagine air here and air here. So when this plane is moving forward, if I come into the reference frame of the aerofoil, then it seems that the fluid is moving like this. So remember, we're talking about fluid dynamics. So even if air was stationary and the plane was moving forward, we will look at the air in the reference frame of the foil. When you look at the air in the reference frame of the foil, you will realize that air here would have to travel all the way from here to here. Now imagine the plane, or this is the wing of a plane, and it crosses a cross section like this. So when it crosses a cross section like this, in the reference frame of the plane, you can say that the air from here has crossed it from here to here, correct? Okay, hello AP. So now what happens is that when the air is moving, the air which is present here in the reference frame of the foil has come up to here. You will realize the air which passed from above this has traveled a higher distance, and the air that is passing below this has passed covered a smaller distance due to the shape of the aerofoil. So what happens is that in the reference frame of the aerofoil, the air here seems to move faster and the air below seems to be moving slower. Hello Shivam, how are you? Okay. Now, a consequence of Bernoulli's theorem is that because the height is same, and so if the height is same, you realize the sum of p plus rho v square by 2 is constant. So if this is constant, you realize if v is greater, then p is smaller. So a faster moving fluid always exerts a lower pressure. That's a consequence of Bernoulli's theorem, right? So here what happens is that the air over here seems to be moving faster than the air over here. The air over here is moving slower. So slow moving air will exert higher pressure and the fast moving air will exert lower pressure. As a result, there will be a net upward force which is called the aerodynamic lift. Okay, so that is one very interesting consequence of Bernoulli's theorem, and that is utilized in airlift of a plane. All right. Now, another interesting application is Magnus effect. So, bending it like Beckham. So, those of you who have seen the Beckham kicks, where Beckham can curve the ball in air, the football in air. The idea behind that is when you kick it with a side. So, you kick it with a side so that you give the ball a spin. Okay. Now, the moment you give the ball a spin and the ball is moving forward, in the reference frame of the ball, if you see, the air seems to be going like this, right? And because of the spin of the ball, what happens is that the air on this region, the air in this region will slow down because the ball is moving opposite to the direction of the air. So the friction due to this ball will slow down this air and it will make this air go faster. Okay, so this air is going faster. Why? Because here the speed of the ball is same as the speed of the air. So this spinning motion of the ball will slow down the air here and fasten the air here. Now, because of this, the slower air here will exert a higher pressure than the air over here. So as a result, this ball will feel a net downward force, and hence when it moves forward, you see it curl. So this ball would have curled like this because it would have been receiving higher pressure from that side. That is what makes curving of the ball that Beckham does possible. Okay. Sir, HCV is complete. Only 10 questions are going out of my head. What should be my next step? Okay, so you can try the questions from Aerodove now. Okay, so I think that's the most logical step. And then attend the class and ask the doubts. Okay, Shivam. In Aerodove, I told you for the chapter of rotation, you should try problems from 1.234 to 1.266, I think. Try these problems. Okay, and then we can discuss that on Sunday. On Sunday, I have a special problem discussion class. Okay, so any doubts that you have can be discussed in that. All right, so let's move forward. So another interesting example is in. Can I go for thermodynamics theory? Okay, yes, yes, absolutely, absolutely. If you feel that rotation is finished, you can even try fluids. That is the next topic. Logically, should be gravitation and fluids. So you can go for that also. Gravitation and fluids. Okay, that is also something that you can do. Okay. All right. Moving forward, as I was saying, another good application. All right, sure. All right. Another interesting application is in a machine which is called the Venturi meter. Now, Venturi meter is a device which is used to measure the volumetric flow rate of any liquid. Hello, Rajesh. How are you? Okay. Now, Venturi meter again works on the principle of Bernoulli's theorem. So, if you have liquid flowing from here, you realize if you know the area of cross sections of two parts. So, let's say the area of cross section over here was A1 and the speed of the flow is V1. assuming that V1 is unknown. Now, for another region, I know the area of cross section A2, and assuming that it is moving with some speed V2. Now, what I can do is I can find the pressure difference between these two by measuring this with the help of this kind of an arrangement. Okay. Now, what you do is you can apply Bernoulli's theorem because the height of the fluid is same here. The horizontal height is same here. So obviously P plus half a rho V square would be equal. Okay, will be constant. So one equation you will have P1 plus half rho V1 square equals P2 plus half rho 2 square. So from here, what you will get is P1 minus P2, 1 minus P2 equals half rho 2 minus V1 square, V2 square minus V1 square. Okay. So one equation you have from here. Second, you have from the equation of continuity. Okay. So from these two equations, you realize in this equation, the only unknowns are V1 and V2. So you can figure out V1, the value of V1 or V2, and once you have done that, you know the volume rate flow of the fluid through it. The volume rate flow would be either equal to A1 V1 or equal to A2 V2, and it comes out to be this. So in this expression, you realize if you know the value of the h, which is the height difference between the two tubes, which are at the different cross sections, then you can calculate the flow rate. Okay, assuming the area of cross sections are known. So using this equation. So this is another application of Bernoulli's theorem. Okay. Next application of Bernoulli's theorem is in giving you the Torricelli's expression. Okay, so Torricelli's expression again is telling you about the speed of efflux. Now, speed of efflux is the speed with which the liquid will come out of an orifice of a container. Okay, so the expression for that is this. Okay. Now you will realize here the container has been closed, so internal pressure is assumed to be P2 and external pressure is P0 or PA, which is P atmosphere. Now, if this container was open to the atmosphere, then P would be equal to PA and this term would become zero. So velocity of efflux eventually would become velocity of efflux comes out to be root 2 GH, where H is the height of this, height of the water column above our orifice. Now, please remember this expression is valid under an assumption where this area of cross section A1, which has been marked here, is much smaller than A2, which is the area of cross section of the container. So this is the expression if A1 is much less than A2. Now, please remember if this expression were not true, then the velocity of efflux equation does not become equal to root 2 GH. That is something you need to remember in mains. In mains, when they ask questions, you generally use this equation, but in advanced, you will find that in most of the questions, this condition will not hold true. So you should know that this equation is only valid under this condition. If this condition was not true, then you will have to derive the velocity of efflux. Okay. Now, once you have the velocity of efflux, the range of efflux can be found out. And you should remember that the maximum range would happen if the hole is made exactly at the midpoint of the container. So this is another standard result that you must remember. So if you have a container, open container, assume open container. Okay. So in an open container, if the height of the liquid is capital H, so for maximum range, a hole should be made at the height of H by 2. You make a hole here, this will have the maximum range of the fluid. Okay. Again, standard result, common result, commonly used result, so you must remember this. Okay. Now, suppose if this expression, this approximation is not true, then what is the equation? Let me just quickly show you that also. Okay, before moving forward, let's talk about that also. So the idea of this derivation is that imagine here is an orifice from which liquid is coming out. Okay, and there was liquid over here. Okay, and there is liquid coming out of here. So assuming this is open to atmosphere, the pressure here is PA, the pressure here is PA. So what we do is we apply Bernoulli's theorem between 2 points which are here and here. So assuming this area of cross section is A2, this area of cross section is A1. So what I can say is, if the height here is h, the height difference is h. So what I can say is, from from Bernoulli's theorem, we will realize that PA plus, imagine the velocity here of the water is V2 and the velocity here is V1, plus half rho 1 square plus rho G H1. H1, imagine, is the height of this with respect to ground. H2 is the height of this with respect to ground. So this should be equal to PA plus half rho V2 square plus rho GH2. Okay. So from here you will realize H2 minus H1 is H. So if I just rearrange the coefficients a bit, what I get is half rho V1 square minus V2 square equals U rho H. Now you realize, for this I can also use the expression V1 A1 equals V2 A2. So from here V2 can be written as V1 A1 over A2. So if I substitute this value here, then I get half rho V1 square can be taken as common, and I have 1 minus A1 square over A2 square equals G rho GH. So this is what you must realize, that rho gets cancelled. V1 becomes equal to 2GH over 1 minus A1 square over A2 square root. So this is the actual expression for the velocity of efflux without any approximations. So no approximations yet. Now, if A1 happens to be much lesser than A2, then what you do is, then this term is roughly considered to be 0, and then the velocity of efflux comes out to be root 2gh. Okay, now please remember that. Okay, again, this expression would be more beneficial for you in advanced, because advanced likes asking questions from this equation more. Okay, so that they want to test whether you understand that that equation is just an approximation, or you have blindly, followed that. So that is why you should know this form, and you should know that that form is only valid as long as A1 is much less than A2. Okay. Now why don't we start with some practice? Right. So here is another interesting problem which can be solved using Bernoulli's theorem. So it says water from a tap emerges vertically downwards with an initial speed of 1 meter per second. Okay. So you must have seen this. If you open the tap a little bit, you must have seen this. Okay, so how does the water stream coming out of the tap appear? Imagine this is the tap. Okay. And if you focus on the stream of water, you would have noticed it comes out like this. So the stream, as it moves down, it goes on thinning. Okay, I hope you've seen that, right? So why does it thin down? Why does it thin down? Have you ever thought of that? It is because of equation of continuity. Okay, this is steady and laminar flow. So you realize, as the water is moving down, the V is increasing. The speed is increasing because of the gravitational force, right? So since the speed of the water as it is coming down is increasing, the area of cross section of that water stream, it starts to decrease. So now you have to tell that if the area of cross section of the tap is this, assume that the pressure is constant throughout the stream of water and that the flow is steady. The area of cross section of a stream which is 1.15 meter below the fluid will be. Imagine at here, obviously the water will have area of cross section which will be equal to the area of the pipe. You have been asked what will be the area of cross section below at a point which is 0.15 meter below the opening of the tap. Okay, so try this. Let's see if you can figure out the answer for this. The area of cross section is A2 here. So what is the value of A2? That is what you want to find. Okay, so that's the great thing about physics. You can actually see these things happening. Okay, so next time if you haven't ever noticed this, you can leave the tap open, but leave the tap on open as to make sure that you have a steady stream. Sometimes when you open the tap too much, then you will see that the stream becomes turbulent. Okay, so that should not happen. Just open the tap a bit. Just make sure a steady stream is coming out. Then you will see that the area of cross section of the stream will go on decreasing as it is going down, and beyond a certain point, when the speed exceeds a particular value, the flow actually becomes turbulent. After a point, you would have noticed that then the water will become like this. Okay, up to a point, the stream will be steady, and then it will break into turbulent flow. Again, we'll talk about that later. But right now, let's focus on this question. Who do you think will be the answer for this? So try it. Let's see. All right, people. Let's see if you guys can figure this one out. Okay. The initial speed has been told to you, initial area of cross section has been told to you. If you can find the final speed, realize you can find the final area of cross section. Okay. Think about this and try and solve this. Okay. Waiting for you guys to try. Okay. So let's see. How many of you can figure out the answer for this? Okay, so first of all, D cannot be the option. So if you're just smart enough, D is actually equal to the area of the tap only. So D cannot be the right answer. The area of cross section should definitely reduce. That is one hint I have for you. Okay. Now, what will it be? So think about this. About this. And let's see how many of you can figure out the answer. So who are trying? Let me know in the chat. Okay, let me know if you're trying this problem. And let me know your answer. Okay. Again, this kind of question has been asked in mains before. So we are trying to take up questions which are very relevant to your upcoming JEE mains. Okay, AP, I am waiting. Yes, sure. So definitely try all these problems. Do not be lazy. So go through the theory. Okay, so AP says it's C. All right, let's try and figure out. So again, so whenever you are solving any such problems, you have 2 points which you have to decide. So let's say this is point number 1 and this is point number 2, so between which I want to apply my Bernoulli's theorem. Okay. So how do I apply it? Let's see. So I can say P1 plus half so V1 square plus so GH1 should be equal to P2 plus half so V2 square plus rho GH2, right? So what I will realize is that I have been told that the pressure is constant throughout. So the pressure is constant throughout. So P1 equals P2. So this and this get cancelled. V1 I already knew. H, let's assume if I take this height to be 0, H equals 0, then the height H1 would be 0.15. So I'll have half into rho of water is 1000 into V1 square, which was 1 meter per second square. That was told to me 1 meter per second. So I would have had half rho v square becomes this plus rho g to h. This should be equal to half to 1000 to v2 square, and this h2 is 0, so I would have had plus 0. Okay. So everybody fine with this equation? I'm just applying Bernoulli's theorem between a point which is here at A1 and another point which is there at A2. Now I can get rid of these thousands, right? If I get rid of these thousands and if I multiply it by 2, so I have 1 square plus I have 1.5 into 2, so 3 equals V2 square. So V2 is coming out to be 2 meter per second. Now the speed has doubled, so the area of cross section, what will happen to that? It would be half. Now applying A1 V1 plus A2 V2, I would have seen that A2 would have been 10 into 10 to the power minus 5 by 2, so 5 into 10 to the power minus square. So yes, in fact, C is the correct answer. Well done, PP and Rajesh. Okay, both you guys got this right. Okay. So for rest of you guys, I hope you followed the solution. What we are doing, we first applied Bernoulli's theorem between points 1 and 2, figured out the velocity at the point 2, and then I applied the equation of continuity. I said since the speed is becoming double, the area of cross section would have just become half. Okay. All right. Now let's move on to a trickier problem. So this problem says that liquid is filled in a container up to a height capital H. A small hole is made at the bottom of the tank. Now the time taken for the tank to empty from H to H by 4 is T1. Okay. The time taken for the okay. All right. So sorry about that. There was issue with my internet, I guess. Now it's sorted. All right, so the answer is C. Okay, okay. A lot of you guys are saying C. Let's see if that is correct. Okay. Hmm. So let's see how you would have approached it. So at any instant, if the height here is h, the velocity of efflux at the bottom, how much will that be? The velocity of efflux that would have been. So just hang on for a second. Yeah. So now can I say that this V would be equal to root 2gh first of all. Now also if the area of cross section here is small a, the area of cross section here is capital A. If the liquid is flowing from here at a rate of v dash, then this v dash would be a v over a, right? I hope you guys can agree to that. Okay. There's some problem in my internet, I guess. It is glitching a lot. Okay, so be patient. Let's hope it just. Okay. So anyhow, I think it will become stable in a bit. Okay. All right. So what I can now say is that you realize as this liquid decreases, the height decreases, and the amount of height that will decrease minus dh, that would be equal to v dash times capital A. Okay. Agreed. So that is dh times dt. In a small time dt, this is how much volume will flow out, and this is how much by which this is the amount by which the height of the liquid column will decrease. Okay. So from here, what I realize is that minus dh over d equals small a root 2 gh. Okay. So from here, what I realize is that dh h to the power of minus half becomes equal to a root 2 g d. All right. Now all I need to do is solve this expression. Hmm. Yes, you are right. You are right. My net itch is fluctuating a bit. So let's give it some time. Let's hope it becomes better with some time. Okay, till then you guys try and focus on the solution. It's just that the net is fluctuating a bit. So if I integrate this from h1 to h2 and from 0 to t, let's see what I'm getting. So I will get the integral of this would be h by root 2 times 2, and from h1 to h2, and that would be a root 2g times t. Okay. All right. So from here I will realize root h2 minus root h1 equals a times g by 2 t. Okay. Just pay attention to the thing, and I will see if I can do something about the internet, by the way. It's just fluctuating a bit. It becomes the net speed is fluctuating a lot. So let's see if you can bear with this. Otherwise, I will probably maybe end the session soon. Okay. So all I need to do is use this expression and compare the two timings. Okay. So from here, you know that from h to h by 4, so root h minus root of h by 4 is equal to k root g by 2 t1, and root h by 4 minus 0 equals a root g by 2 2. Okay, so from here what I will get is essentially t1 equals t2. Okay, I hope you can see that. You can write this as this is root h minus root h by 2 equals root h by 2 equal to root h by 2 again. So t1 is to t2. D is the correct answer. 1 is to 1. I hope you follow. The correct answer for this is 1 is to 1. D. So the time that the uh, tank is taking equal to the time it takes for the rest. Okay, so the thing is that there seems to be some issue with my internet that is just not getting resolved. So I think what we will do is we will wrap up the session here, and then maybe we will continue this session tomorrow. Okay. So there is a lot of issue with my internet today. I don't know for some reason. So let's just wrap up today's session here, and we will continue the session tomorrow. Okay, so that is it, guys. Unfortunately enough, the internet is not allowing us to carry on with this session. So before I wrap up today's session, again, let me just remind you a quick bit about how you can get yourself the Unacademy subscription. Okay, go to the plus section of the app, select your goal as IIT JEE, and click on that get subscription button. Okay, and next, when you redirect it to the payment page, what you can do is you can use the code RDLive. Okay, and that is where unfortunately we'll have to discontinue today's discussion. And you can proceed. You can click on proceed to pay, where you would have chosen a lot of convenient payment options. Again, gone for any of those two subscriptions, plus or iconic. The plus subscription would take your JEE preparation to the next level. Okay, so the net seems to be improving, but again, I don't want to take a chance. Okay, but because it's still fluctuating a bit. So let me also remind you that you can compete live in the next Unacademy Combat event, which will happen tomorrow. Enroll now using the code RDLife and win yourself some cool prizes. Now, the top educators from Bansal are also teaching live in our academy, so you can enroll in their courses. And the Spark batch for 2023 is starting. Now, if even after all these lags, you still like that, like today's video, okay, so again, my internet, yeah, internet is still lagging a huge bit. There is issues with my network, and I think it's a good call to just end today's session right here. Okay. Next, if you like the video still, don't forget to press that like button. Anyhow, okay. So that is super strange. I will see. So let me just end the session and let me try and see what I can do about this internet. Okay, and then we will carry on with our discussion tomorrow. So till then, I'm sorry for today's inconvenience. Okay, the net has been absolutely fluctuating a lot, and I don't know. I can't figure out the reason for that. Okay, I've checked my settings. Most of the settings look all right. There must be some glitch with the software, which I'll get checked. And tomorrow we will resume a smooth going session. All right. Till then, let me remind you one last time that my code is RD Live. So if you're planning to get yourselves the Unacademy subscription, this is the code that you can use. And I'll see you tomorrow then with the further discussion.